Yeah, we're live. I think I'm early. Let me check the time. Yes, I see the extended version of Super Richie Live. Tonight we're talking about valves, the piston to valve clearance video that I just put up today on the 5-liter Ford, but actually it works the same way on most motors. All that you have to do is figure out where the closest point is and then measure that, and we set up a dial indicator. It's all actually fairly easy. That's the way that I normally do it. I've done it other ways. I've done it with clay. I've done it with, I guess I've only done it one other way. Usually when I do this, or oftentimes when I do this, we'll also include, a cam degree wheel so we know exactly where things are. But what usually happens when you're measuring piston to valve clearance is the critical areas are going to be 10 degrees before and 10 degrees after top dead center, and depending on whether it's the intake or the exhaust. And then what you do is you can just swing it from there. I like to rotate the thing all the way around just because I like to know what if there's some magic thing happening somewhere that we don't know about. There obviously isn't, but I like to test all that. So what I do is I just spin it around and find it. Okay, it's not here, not here, not here. Oh yeah, it's starting to get close, starting to get close. And then you get to a point where if you've done it enough times, you can feel where the tightest point is. You may have to wiggle it a few degrees or whatever either way, but you can tell, okay, that's 300 thousandths, that's 200, that's one, oh, that's only 50. You'll get a feel for it. With the stock camshaft, obviously you have lots and lots of piston to valve clearance because it's a stock cam and that's what they do. When you start putting aftermarket cams in, you obviously have to be concerned with that. With every kind of factory application, they didn't give you unlimited piston to valve clearance. They gave you some. They gave you some extra depending on the application. Like with an LS, we put, and the thing is, it varies dramatically with camshafts. And I was talking to Billy Godbold about that, who it's always cool to talk to Billy because he's so knowledgeable about everything. He thinks about these things differently than I do. For one, on a different level, but also on a different trajectory. So there's lots of things going on there. But one of the things that he mentioned is that, and he got a kick out of this too, because we were talking about people asking about different lift. How much lift can I run? I'm like, yeah, I don't know. You could run all the lift. It doesn't matter. He said, yeah, I usually tell people you could run between 2 and 2.5 inches. He said, because when you measure the valve at maximum lift, where that happens, the piston is at least 2 inches down. So if you've got a 2-inch cam, you're doing pretty sporty because most of them, most motors that I know of don't have 2-inch cams. The other thing that's interesting, obviously, and what plays a big part in this, and you guys can comment, is obviously the valve events, the opening and closing points of these things, when they happen, what the overlap is, all of that stuff plays a point. Because we were talking about, I asked him to look up how much of a change, going from, in this case, it was from a 274 cam to a 282 cam for the 5-liter. I said, how much, once we know one of those, like I measured a 274, I also measured the stock one, but once you know what the available piston to valve clearance is on the 274 cam, assuming that you did it correctly, because I've done it not correctly a couple of times, assuming you do that correctly, what is going to be the change from these valve events on the 274 cam to these valve events on the 282 cam? And so he could tell me that's about 25 or 26 thousandths. So the nice thing is when you do and measure piston to valve clearance, you don't know just what it is for that camshaft. Now you'll know what it is for other camshafts too. In this case, we know that we could step up to a 282 camshaft because the available piston to valve clearance is more than the amount or that it would decrease with the bigger camshaft. And one of the things that Billy was doing for me and that he was playing with is that by juggling the valve events, primarily just widening the lobe separation angle, because we talked about what people do in pro stock applications and things. So it's fairly cool. But if you widen the lobe separation angle, you can run more duration, probably more than you should on a stock 5-liter Ford, certainly a lot more than you should. But if you widen that out, you can run a lot more duration because it helps with available piston to valve clearance. It may or may not help with power by adding a whole bunch of duration, but that's the thing. That's why all of these valve events are very critical, and you have to tailor them not just to having more, because first of all, if you have a 5-liter Mustang with a stock head and a stock intake manifold, you're not going to want lots of duration because it's going to want to make power pretty low because all the rest of the stuff is going to sign off way before that. But you could do it if you wanted. And the other thing, like we talked about, is you can run as much lift as you want. You can run really high lift cams. What you start running into with, if you run a duration and a reasonable LSA in a motor like a 5-liter Mustang, where you would limit RPM because it's not going to want to rev anyway. What you would run into, though, is if you want to run lots of lift and short duration, you run into ramp rate problems. You run into instability problems. You run into valve control problems. So you run into other things that are not related to piston to valve clearance. It's a real dynamic equation. But this was cool because it's been a really, really long time. It hasn't been that long since I ran a 274 cam, because I ran one in the Marshall Motors rebuild one that I have. I just didn't know what piston that was. I didn't know if that was the same, like a reproduction of a factory 5-liter piston, so that it would give me the same numbers for available piston to valve clearance, because that's what I wanted to supply to the 5-liter guys. I wanted to give them, let them know, here's what happens. And the motor that we tested on that belonged to Mark Sanchez was an unopened, I think it was a 1990 or 91 5-liter Mustang. So it's the way that it was stock. It's a factory piston. It's a factory head, and we ran it with a stock camshaft. And I was told today that, and it surprised me, Mark told me that the automatic and the stick cams are the same thing. I thought that, looking back, that the stick cam was different than the automatic cam, but he said that the part numbers are the same. So I thought that was interesting, because for years and years and years, I've been telling everybody, yeah, we compared it to a stick cam. I've been saying that, and maybe that was incorrect. I was also incorrect in my discussion with somebody that I had. Somebody sent me some sort of communication, email or comment or text or whatever, about measuring piston to valve clearance with a camshaft that I thought was quite a bit too big for what the combination that they're telling me about. And it might be that I was more than likely wrong about that, judging by the piston to valve clearance that I got during this test. It surprised me. There was a lot more available piston to valve clearance with this combination. Now, I've run 274 cams in stock stuff before, so I knew that they fit. I just didn't know by how much. And so now what I'm going to do for part 2 is, I've got those airflow research heads with bigger valves. I think that they're 202 valves. And so we'll put those in, and we know that that 202 valve is going to overhang the valve notch, the factory valve notch in the piston. So we'll see how much just the valve change with the same camshaft affects piston to valve clearance. And then again, it won't just tell you whether you could run that with that camshaft, although that will be interesting to see if that's even possible. But it also tell you if you can run something bigger than that, which would be nice for an aftermarket head like that. I know that on that Marshall motor, we've run that camshaft, and we've run it with heads that have that CNC port head might even have bigger than a 202 valve. So I can't remember now. It's been a long time since I put it together. So, but we know, well, I don't know how much piston valve clearance it has. Maybe it has 3,000s. That's the other thing. And the thing that, and I discussed this in the video, is that when we're measuring these, there are a lot of things to consider. One is that we're measuring it in a static environment. So I'm just, the way that I did it is, Mark put a nut on top of, we took the guts out of a hydraulic roller lifter, put a nut on it, and then use that as our solid roller lifter, so that we didn't have to worry about depressing the lifter, collapsing it while we were running it with these springs, even though the springs are they're kind of tiny. I'll show you. They're just checker springs. So they're just checker springs. So they're not very stiff. But even these on I don't know how long that motor's been sitting, but you don't want it to move that like 20 or 30 or 50 thousandths or whatever, and then it throws off your whole thing. So if we make it solid, and I was going to come to Westec and just get a solid lifter, and then what I did was get an adjustable push rod, and so I can adjust it, take all the lash out of it, we're not preloading the lifter, and we're not pushing the spring down. We just get it to zero lash basically, and then when we spin it, every time we do it, we recheck it and make sure it zeroes back in the same spot, and it always does. There's enough spring rate here, and with our solid lifter, it worked out very well. But we didn't have to worry about, depressing the lifter, which is good. But the other thing I was going to talk about was that even with springs like this, we're not inducing any deflection into the system. One, we're not introducing any deflection because it's not a dynamic equation anymore. The motor's not running; it's just static, it's just stationary, and it has like wimpy little springs. So just the spring pressure alone will cause the standard spring pressure and upgrade to ones even more will cause deflection. And then the dynamic equation will also cause deflection. So you'll actually get more in a dynamic equation, you'll get more piston to valve clearance. You will increase piston to valve clearance probably by, in talking to Billy, we're thinking that it's 20 to 25 thousandths, depending on the things that you have. The push rods are really short on these 5 liters. So, maybe they're not bending as much. It's going to depend on the strength of the rocker and how stable the cam is and a lot of stuff. But if you add another 25 thousandths of available clearance while you're running, you don't want it to be binding and have to start it up to get that 25 thousandths clearance. If you only have 25, that's probably not a good idea. But it's, you can think of it as like a little extra safety margin while you're running that will definitely happen. So that's another part of the equation when you're checking piston to valve clearance that you should know is going on while you're doing that. And then, so if you're right on the edge, you got like, okay, I don't know, let's pick a number. Let's say a lot of times they want you to have 100 thousandths. We don't ever run them there. we're way to the southern side of 100 thousandths clearance. But let's say that you're running it at, I don't know, 40. And you're like, 30, 40 is getting a little tight. But then you got the extra 25 in there. So, you're probably okay. So the next thing is the trophy 4-cylinder. And that's going to be the poll for tonight. There's not a lot of people here right now, but we're going to just get our poll going anyway. Should I do a video of the timing gear on the trophy 4-cylinder? Okay, should I do a disassembly video of the timing gear on the trophy 4-cylinder? Who wants to see me take that front part of it apart, essentially, on video? I don't do a lot of disassembly videos. I think that they're cool. I think the I Do Cars guys, he's very, very popular. It surprises me. Not that he's not doing a great job, because I watch it all the time. It's just that it surprises me that people like watching people disassemble. I think that's awesome. And I like hearing about, because I'm an other guy's kind of guy. So should I do a disassembly video on the timing gear on the trophy 4-cylinder? Because it's one of the comments that I got a lot of saying, hey, look, that chain is stretched. And I showed you guys last night how much deflection that there was, how much movement there was in the crank before the distributor decided to join the party and move. Some of that obviously is lash in between the camshaft and the distributor, and just general slop in a distributor that was manufactured back in the very early 60s. So, but I do want to take that apart, and I think I'm going to do it on camera and talk about it, see what's going on. Because the other thing that's happening is this trophy 4-cylinder now is off the dyno, and I'm not going to be doing any more testing with it on this adventure. I'm taking it over to I think it's BMS. Yeah, BMS machine in San Bernardino. David's gonna take a look at it, and basically what I want him to do is, wait, did I not ask my poll there? Oh, there we go. Sorry about that. The poll's up. He's gonna take a look at it, and what I told him was, first of all, thank you very much for offering to do some machine work on this. That's very cool because it obviously needs it. So I'm thinking what I told them I wanted to do is a flat top piston, bore it out to 400. We want to fix the head, do a proper valve job and stuff on it, and maybe do another head. I have aluminum heads coming as well. I'm going to send the cam out, that cam to be reground, and I'm also getting a different cam in. So I'm thinking about regrinding that. If I'm going to regrind it, I'm going to regrind it to whatever profile the regrinder has. And that I have available to me using that core, because there's a limitation to how far you can go. So we're going to have to change something, obviously, because it's going to be a small base circle cam when it's done. So hopefully that doesn't upset the lifter position and oiling too much. Obviously, the rest of it we can take up with push rod. And obviously, a lot of other guys are recommending that we go from the 1.5 to a 1.65, which would increase lift by 10%, which in our case would be another 33. It'd take it from 330 to 363, which is not going to be a lot. I mean, every little bit helps, but it really needs more camshaft. And then I obviously want to do a later head on it so I could do all the intake manifolds and all that stuff. And I'm going to talk to the guys again at TorqueStorm about doing a TorqueStorm supercharger for it to start off with our boosted stuff. But before we do that, we want it to be making some power. So it's going to go over there but while it's there, I want him to tell me, how bad is it? How wavy are the walls? How bad are of my Super Ritchie razor blade rebuild? How bad are the valves leaking? And all that, just stuff that we'll know from a machine shop, and then that way we'll know what happened before and then what happens afterwards. And so hopefully we put it back on, and we would see a fairly sizable change in power. So that will be fairly cool, because then we'll have a new starting point. And if we're making, maybe we can go from 100 to 150 and then to 200 and then 9,000 or whatever the next jump is. It's going to be big, though, whatever the next jump is. So that's what we're doing. Right now, I'll show you guys. They're setting up for Engine Masters. You can see all of the... That's not like my camera stuff, right? So you can see they're... start filming tomorrow, I think. And here I am, standing here talking to myself. Okay, so let's see. I want to see how the poll's doing. I want to see what people are saying about taking this thing apart on camera. So 48 votes so far, 88% are saying yes. We'll take that as a yes. Everybody get out there and vote, and also hit the like button. Like, share, subscribe, ring the bell. Yeah, the poll. I got sidelined. I got excited and wrote the poll and thought, okay, I've done my job. Then that's it. Let's see. 6% says no so far. They're the no group, I know. They're all the cool guys that hang out over in the smoking section. You should do a Haggerty style video where you clean all the crud off the junkyard engine and make it assembly line fresh when you put it back together. It is going to be all painted, and it'll be all nice and pretty when it goes back together. I've got a polished aluminum valve cover for it, and obviously we've got different intakes. I'm going to clean off the aluminum front cover so it's aluminum and not painted. I'm painting the pulleys. And the other thing I'm thinking about doing as one of the tests, I'm going to talk to some of the oiling guys, Milodon or Moroso, and see about another pan and an oiling system upgrade. I remember Andy did something on one of the Pontiacs. I think he did a crank scraper and maybe also a windage tray that was integrated into the pan. So I'd like to do an oiling system upgrade. This had a baffle and a small flat tray maybe, but it needs to go all the way across. It needs to wrap, and it needs to be a proper windage tray, maybe a screen or something, because it looks like, if I remember right, I know that the 400 has it. I'm hoping that the main caps, I'll take a look at maybe the main caps have provisions to bolt on something. So if I could put a windage tray on there, or one that's incorporated into a good pan, the awesome thing would be a pan with a kick out. That's something I could actually weld and make. But, an oiling system upgrade for that. One of the things I want to get rid of is the swinging oil pump. I just want that. I'll feel better if that's just stationary and at the right depth, so we know that's all working okay. And then obviously another timing chain will go in there, a proper one that's tight. And for guys that weren't here last night, because I got lots of suggestions on the videos wanting to know, they said the cam's flat and all that. The cam is in perfect shape. I say perfect. It measured out within a couple thousandths of all of the lobes were consistent, and they were all what they were supposed to be, both on the intake and the exhaust. The rockers look like they're in good shape. These are the factory push rods. All that looks like it's doing what it's supposed to do. The thing that I don't know about is when I do this video, because I'm definitely going to do it, so regardless of what the poll says, but I want you guys all to vote. If I take apart that front cover, I want to see how much slop there is in the chain. And they will know, you know, because if they're slopping the chain, unless the tensioner is saying otherwise, it's going to retard the cam timing. And while that could be beneficial on the right kind of motor that actually runs some RPM, this is not that combination, not a 4,000 RPM motor. Lunar Outlaws, it was really awesome to see, awesome to help out with the T37 Roadkill episode. Steve and Dave are really awesome. Steve, Brian from the Hemming shop says hi. Okay, cool, yeah. He left earlier, but he'll be back tomorrow. Don't go chrome it. I actually want this motor to look good too. I want it to have good eyeball. Terry, I'm not sure why, but I want to see the Trophy 4 make 400 plus horsepower. How about I guarantee you that it will do that? Yeah, these valve springs weren't, that's right. Yeah, and these valve springs weren't strong enough to flatten the cam lobe. What is the purpose of small but Chevy 1.5 versus 1.6 roller rockers? Why would you use one versus the other? What are the benefits and the negatives? The benefit basically is that you get more lift. The potential downside to that, and more lift can make more power. It doesn't always do that depending on what the cam lift you already have versus other things that are going on in the motor. And the other possible downside is that you can get into not piston to valve clearance because you're only changing the duration by maybe 1.5 degrees or 2 degrees, but you can run into valve float issues with a rocker change, and so you might need to do a spring upgrade. So you may or may not get power from it, and you may or may not get valve float caused by it. You definitely will if you're on the border of having enough control with a 1.5 rocker. Just going to a roller rocker will usually induce valve float earlier than it does on a stock rocker. So those are all things to consider. Canton pans are better. Crank scraper is good. The roller cam, not sure if it helps with the flat tap. A crank scraper is going to help regardless of what camshaft is in it, because it's going to get oil off of the crankshaft, and that's what you're trying to do. That's less weight and less windage. Let's see. Oh, I had asked about the low lift, long duration cams. You mentioned the piston to valve possibility being an issue. Yeah, the lift doesn't do anything. Maybe you could test that, please, like 450 lift and 240 to 250 degree duration. That's basically what that cam, almost what you're saying there, is basically the Duntoff cam. For it's a solid flat tap it, but that cam was, I think, might have been 480 lift, but it was in the fours. It was in the mid to high fours, and it was 254 degrees of duration F50. So they work, and it'll extend the RPM, and they tend to be more stable to run RPM because you have low lift. So it does work. What happened to clay testing the clearance? I talked about that earlier. You can do that. I've done it with I've done the Play-Doh stuff too. It's just that you have to take the head on and off a bunch of times. Also, for camshaft mock-up, would a flat tap have any issues checking cam timing, or would it instantly trash the lobes and lifters? Should oiling surfaces solve the problem? If you're just checking for mock-up, you should have oil on everything anyway. If you're just checking for mock-up, you're not going to have a problem. And if are you checking it with stock springs, or are you just checking it with checker springs? Because with checker springs, you're never going to hurt it. Will a Trophy 4 make a good swap engine for Chevette? It would be awesome because it would be very, very unique. Chevettes are fairly common cars to swap stuff into, and that's because they're awesome. But I don't know. I don't know how many Trophy 4s there are out there. Is there room on the base circle of the cam to regrind it for more lift? On the Trophy 4 cylinder, I'm told yes, there is. How are we doing on our poll? 86% saying yes, 14% saying no. Disassembly video, it is. Disassembly, and get the likes up, yo. Never done a flat top before. Don't worry about even the slides marring on the surface. you need to look at what these motors are that I'm running, because there's marring on the surface, most definitely. Yeah, we're at 64 likes right now. At least that's what it's showing me. Where's my... Oh, there it is. Hang on. Frosty cold beverage. Wow, it's not very cold anymore. There's no frost. All the frost has left the building. It's really hot in here. It's getting hot in here. Dan, I think that there are guys that can weld the cams up. More videos on anything motor related. So just more videos, basically, just more content. Because the only thing better than content is more content, right? Richard, do you ever duct tape your engines together before you just have a big turbo on them? We were going to do, Chad and I wanted to do the finger tight build, just put all the bolts together finger tight, just to see how long it would last. Eric, so you ground down the base circle, so you made a different cam profile basically from your stock one? Michael, would a Pontiac V8 cam work on a trophy 4-cylinder? No, it won't. The problem is that the firing order is wrong. I mean, it will make the valves go up and down because they're going to be positioned in the right spot. It's just that they're not going to be doing it when the piston is in the position that it wants to be in. The top ring of my LS doesn't have any dots or markings. Does that mean it can be installed either way? That's what piston manufacturers normally do, and it normally says that. It said that on these Hastings rings that I got from the trophy 4-cylinder, that it'll say up, it'll have a dot, it'll have whatever, some sort of marking. If it has no marking, it goes either way. The other thing I like to look for, if it doesn't have a marking on it, look at the edge, look at the inner edge of the piston. If it's got a chamfer on it, it might actually be directional. What causes a cam to break in half? I've actually broke a cam in half on my Z when I put it on in the wrong spot and it wouldn't turn. So I was trying to turn it, and I was trying to turn it with a big pipe wrench. And I ended up finding out what the breaking point was the cam. Oh, by the way, I also bent some of the valves. Have you heard the LS12 in person? I think that they had that at SEMA when I was there one time. I think that I did hear that thing start up. Richard, do an IHI 392 or the 196 slant 4. I haven't seen those, but yeah, those are cool too. All else the same on a stock 78-75 turbo cam, only 5.3. Which cam would win an 8th-mile race? Are you going all out on the turbo? And what stall speed do you have? All of that stuff will come into play. The best cam will have better response, and the sloppy cam will make more NA power on the top. But I honestly think that the 78-75 is going to make the same power at the peak with both of those cams. So it's all going to be based on what happens at the beginning of that race. And I don't know what your stall speed is and what your weight is or what your gearing is or any of that stuff. So that cam shootout is going to come at the beginning. Has anyone ever done a performance build on a trophy 4-cylinder before? Yeah, there's lots of YouTube stuff up there. Somebody sent me a video or a photo today of one with Mickey Thompson did one with a little roots blower, probably a 371 or a 471, and also a Hemi head on it. Was talking trucks with a cowboy coworker today. I was thinking LS7 long block, ported TBS intake, Chuck Norris cam. What heads are you going to put on that? If you have a TBS intake, you are going to have to put a cathedral port head. Cameron, you may have been the one that was talking to me about the Delta cams. Yeah, I read your email. Cameron says, "Hey Richard, hey folks, I'm close to Delta Cams. I went and talked to Ken over there today. I told him what was going on here with the Trophy 4, and he said 4,700 RPM. We can get that well into 5,000. And the thing is, at 4,700, it's not making any power. That's already 1,000 horsepower past the power peak." Larry, when I took apart my 88 L98 Corvette, some pistons were stamped with letters and some with numbers. The numbers didn't correspond to the proper cylinders. This motor was never apart. What gives? It may have been the way that they numbered them for some other reason other than the cylinder number. It could have been a bin of this one has this kind of clearance, and they're matching that clearance to the clearance that's in that cylinder. Honda did that stuff with their rods and main bearings. They put combinations together, an A, a B, a C, a D, whatever, and so they made sure that they got the clearances that they wanted each one of them. Crank, do you have a video that shows the trophy crank? I think I did show that from underneath, maybe. It's a typical 2 up and 2 down kind of thing, like you see in every Honda. Maybe try an M90 on the Trophy 4-cylinder. That actually would be a pretty good match for it, I think. An LS7 long block, you need an LS7 intake. You don't need an LS7 intake for an LS7 long block. It depends on what cylinder head you put on there. If you put LS3 heads on there, then you can run an LS3 intake. If you put cathedral port heads on, you could run cathedral port intake, because the LS7 block is not, it's the same deck height. So it doesn't care about that, but it is a big bore, so you need a cylinder head with a chamber that will work with that 4125 bore. I'm not LS savvy. Homeboy's interested in the lifestyle. Wanted to swap the 4.3 for a 5.3. Made a couple suggestions. Have you ever used Howard cams? I have a couple of times. Yep, Karen 5.3 and a turbo. That's a pretty good advice for most combinations. Still at 85% on our poll. Richard, do you have any preferences for aftermarket ECUs? I think you've been here enough. You know what the answer to that is. I only run the MS3 Pro and the Holly, and I haven't run the Fast, but I've run the Fast a lot back in the day, but we don't use it nearly as much now. But I know how, and I'm not really the right guy to ask for preferences anyway, because I'm not a tuner. All I do is more air fuel or less air fuel, more timing, less timing. And you know, it's fairly simple for wide open throttle stuff. Do you have another 1-barrel intake for the T4? How about putting injector bungs in the manifold? The thing is, that's not going to help. Having it be fuel injected is not going to make anything any better. In fact, I'll bet if I put port injection on it and just put a single throttle body on it, it'd make less power than the carburetor does. Really, the ticket would be if I had somebody that could weld this manifold. I want to put 2 more of those 1-barrel flanges on there, so that I can make it. It wouldn't be a tri-power. It would be a 4-cylinder tri-power. There would be 3 of them, but it's 3 1-barrels. And so I just wanted to do that because I think it would be cool. It obviously would, and it wouldn't ruin the manifold, because I could, if I ever wanted to run a 1-barrel again. The other thing I could do is, because I have that 1-barrel to 2-barrel adapter, I could put 3 4412s on it. You know, it looked like a 6-pack for a Dodge, because he would run Hollies on it. If they would all fit and actuate, it's pretty tight in there if you had the 3 2-barrels on there. But 3 1-barrels would be kind of cool. Let's see. Do you have another 1-barrel? Okay. Did I ever ask you about the 1-to-1 boost reference on a fuel pressure regulator valve? Do I pick one, or can I adjust both for a ram air intake setup? I don't know what the ram air intake one. A 1-to-1 reference is very typical. It's that way for almost every fuel pressure regulator. unless they make it different, unless they specifically make it different. So any sort of regular bolt-on regulator, almost all the factory fuel pressure regulators, Mustangs and Camaros and just everything, is 1-to-1. So if you have a reference line hooked up to it that sees both vacuum and boost, it will reduce the fuel pressure under vacuum conditions, and it will increase the fuel pressure under boost. But under boost, you're only increasing it the amount of boost that you have. So you're just keeping the delta fuel pressure the same by doing that. So it is improving the fuel flow, because otherwise it would be reducing it if you were just blowing. And we do that a lot of times where we don't hook a regulator up. And we do that because we have way more fuel pump than we need, and we have way more injector than we need. So we can always give it enough fuel. But it's a good idea to have that reference, especially it's nice, kind of nice on bigger injectors, because if you have a reference line hooked up to the fuel pressure regulator, one thing is if you have really big injectors, you can lower the static pressure, but also hooking up a vacuum reference line to that while you're cruising around reduces the fuel flow even more. So if you have trouble tuning big injectors for basically low power situations, that kind of helps you along. Is it difficult to find a cam core for the trophy 4-cylinder? I would think they didn't, the Delta Cam guys or whoever didn't have any. I would think that it is, because it wasn't very popular. They didn't make a lot of them. Snafu, they're all very easy. The Holly thing is really, really easy to use, but it's like everything. Once somebody shows you what buttons to push, it's it's pretty simple. Can you run individual track two-barrel carburetors? I mean a two-barrel for each one? Yeah, Karen, I'm with you. I don't have LS7 money, but even if I did, I'd use a 5.3 turbo. I would pick a 5.3 turbo over an NA LS7 in any day, even if I could, even if I made LS7 money. I make junkyard money. For motorcycle carbs, that's been suggested a lot, actually. ITBs off of Hayabusa. You need to go to the Hayabusa junkyard. Will an old school nitrous cam work with turbos? Yes, anything will work with turbos, and anything will work NA, and anything will work with nitrous. It's just your starting point. It might not be a good starting point to begin with, and then where you go from that starting point is also, I mean, it'll be better because it's boost, but it might not be ideal. But you can run boost with whatever cam that is. Are you going to put the 7875 on the trophy 4-cylinder? It's probably a little presumptuous. I need a 2825. Can you get Pro Charger to donate? I don't really need a Pro Charger. I already have, the thing I like about the Torque Storm is, and Pro Charger has them too, they're self-contained, so you don't have to put holes in the pan. I'm going to have to do that anyway for a turbo. But I already have the Pro Charger. I have a Pro Charger because I have a bunch of different Pro Charger kits that I run the same head units on. I have two of them, so we could run two of them if you want to run two of them on the 4-cylinder. But I already have the Pro Charger, so all they have to send out is basically the Pontiac kit, the rest of the Pontiac kit. If a regular V8 can physically fit in the trophy 4-cylinder, can't comp cams grind a custom one? They can. They're already going to do that. I'm going to buy a cam from them that will be a hydraulic roller cam, actually. Did you solve the T4 water pump dilemma? I think that it's right. The vanes on it, from what I gather, is that the vane depth determines whether this pump supplies water flow to all 8 cylinders or just to 4. And this one's supplying it to all 8, although 4 of them are not there. So I think that it is working. Lunar Outlaws, the VPMS 109 fuel is good fuel. So you have a 1UZ, all right, coil unplug. Yeah, just get the plug gap right and get the dwell right. And a 2300 supercharger will make good power. 5.7 liter LS1, do I leave the stock crank and do new rods? I want 750 to the tire. You can actually do that with all the stock stuff if you put ring gap in it, but I'm not a big fan of those blocks, but 750 is still within the strength ability of that block. You won't hurt the crank. That is the same crank that we've run 1500 horsepower with, so you don't have to worry about the crank. If you want to do an upgrade rod and piston, it's a good idea. Will the trophy be able to make 600? So now we've upped it. I just promised 400, and now it's 600. Anything's possible with the right amount of boost, I guess. So if we could get this thing over 200 horsepower NA, which I think is certainly possible. I mean, if you look at, if this thing is 194 cubic inches, making like 1.3 or something horsepower per cubic inch is not like it's not like an Engine Masters build where you're making 1.6 or 1.7 horsepower per cubic inch. 1.2 and 1.25 or 1.3 is just a good street motor. So that should be possible. 1.3, you think about it on like the way that I do the math, it's always like on a small block Ford. So if it's a 300-inch small block Ford, 1.3 isn't even 400 horsepower. So 400 horsepower Fords just are are falling off the truck. It's really easy. The V8 cam I don't think is longer than this because the head is the same. You think a 1-to-1? If you don't, you are racing. Don't you already have a 1-to-1 regulator on it? A 1-to-1 regulator is not. It's just universal. They're all like that. Modify a more common 4-cylinder cam to fit the trophy motor. We don't need to do that. We have cams. we have the technology. We'll get one reground as a flat tappet, and then we'll do one hydraulic roller that's a little bit more business oriented. Because I mean, if you have think about it, if you have a cylinder head that flows 300 CFM or more, and you have 10-to-1 compression, and you put a single plane or a good dual plane intake manifold on it, and with that kind of head flow and the right camshaft, you should be able to make pretty good power. What about building a long rod trophy motor? The rod ratio thing is not something that I subscribe to. Dan, you forgot to put the word budget 2.2 Jessel rocker setup in front of that. What I'm asking is, I have an aftermarket regulator I'd like to install, and I'd like to set up a ram air intake. Both of those are yes. Richard, what do you think of the twisted carb Edelbrock Torker intakes? So like the Tarantula and the Scorpion intake manifolds, where it looks like they took a Torker 2 and heated it up and rotated it. I've seen those. I haven't seen one for a really long time, and I don't think that they're making those anymore. I need to ask. I'll bet Freiberger or one of those guys has one of those that we could test. Fascist, that's right. The banks are offset. One of them is farther back. I don't know if this is the farther back side or the closer up side. Twisted them for fuel distribution. Yeah, I think that they, if you tested a modern Super Victor or something compared to that, it would be a lot better. Does the V8 flywheel bolt to the trophy 4-cylinder? Yes, that's what we have on there on the dyno test, because the flywheel that came off of there has no bolt holes to mount our drive plate on it. Otherwise, we could, but It just doesn't have any holes. And we could center it if the crankshaft had a provision, or I think it has a provision for a pilot bearing or a pilot bushing. So if we had the pilot bushing in there, we have our spline coupler for the drive shaft on the dyno will go right in. The pilot shaft will go right in, and it would locate it, and then we could mark it and drill it if we wanted to. But we already have a Pontiac flywheel, and that just went on. Larry, yeah. Once we get the NA power output up on his question was how about some nitrous on the Trophy 4-cylinder? I try to run a small shot of nitrous on every new motor that I put on there, just because it's so simple. We would run a 50 shot or something on there probably. So, but I want to get the NA power output up before we do that. 220, 224, 575 lift, I'm sure is a different cam. Want to use a VS Racing 78, 75, 75 to the tire. No, a 224 cam with that turbo will easily do 750 at the tire. Are you going for higher than 10-to-1 compression? No. Nope, 10-to-1 for me is kind of the sweet spot. And we'll see exactly how it comes out depending on what piston that they have available and what the chamber volumes are of the heads that I have available to me, because they're, I'm going to use the ones that are here. Yeah, Matthew, you can make 750 at the tire with a 1,000 horsepower turbo fairly easy with lots and lots of different camshafts. The camshaft wouldn't be holding you back. You could do it with a torque cam. You could do it with a truck Norris cam. Sloppy stage 2, sloppy stage 7, all the sloppies. What kind of horsepower do you think a 5.3 with a 70 millimeter turbo with a decent cam? Again, the turbo is going to dictate how much power it has. And I've seen 70 millimeter turbos that flow wildly different and can support different horsepower numbers. But that if the one that you're talking about that's very similar in size to the GT45, and that makes it a 750 horsepower or so flywheel turbo. A V8 flywheel might bolt on, but it's not the right balance. It's neutral, right? Water methanol injection for octane boosting charge cooling benefits. Yes, it does both of those. It will lower the charge temperature, and depending on the percentage of methanol that you have in there, it will add octane. It just doesn't do what an intercooler does. It doesn't add power, really. What's the bore and stroke on a Trophy? It's the same. Oh, Car Farm, what's up, guys? I've got some information for you. It's the same as a 389 Pontiac, so it's a 4062 by 375, if I remember right. What are you looking for lobe separation on the Trophy 4-cylinder? I need to see what they have. He's got the Delta guys have some kind of cam profile that they've already done for these. Ideally, what I would like for a flat tappet cam is I would like a Trophy 4-cylinder version of like a Ram Air 3 cam that's still streetable enough, because if you go to 4 or 5 or 7 or whatever, that's too big of a jump. I'd like the flat tappet cam to be more drivability oriented. Ram Air 3 cam specs in that would be awesome, and it would be a big step from what's there. So you'd be going from you'd be changing it by 40 degrees of duration or so. So it's going to be quite a bit. And then I'd like the hydraulic roller to step up from there. Does more intake duration make a turbo spool later? More intake duration than exhaust duration? I don't like those cams. I don't like those asymmetrical cams or the reverse pattern cams. But a bigger cam, which is more intake and or more exhaust duration, I call those bigger cams, will make the turbo not spool as well. Smaller cams anything that makes the NA motor make more low speed power will make more low speed boost. Daniel, GT45 on that Pontiac should make 175 horsepower at 24 pounds of boost at 6,000 RPM. So there's a lot of things wrong with that math. First of all, this motor won't go to 6,000 RPM. And I doubt very seriously that it would make anywhere near that much power, even at that boost level in its current configuration. Maybe you're thinking about after we do other things to it, but it wouldn't do that now. Is the machine doing block work or head work? They're doing head work also, is what I'm thinking. I talked to them a little bit today, and they're definitely going to do surfacing the head and valve job and stuff. I don't think we're doing any porting. I'm not going to ask them to do that because I don't think it's necessary. I'd like the heads just to work, and then put it on and run it, and then we'll go up. If I need port work, I have aftermarket aluminum heads that can satisfy that. It's all valves basically. What's the company that Mike Brewer took a cam to? They welded it up and gave it a custom grind. I don't know. There are a couple of custom grinders. The Schneider guys do good work. There's one up in Oregon that does work, and then Delta, I think, is another one. Where did the reverse pattern idea come from? I don't know. I don't know what the science is behind that. Maybe I need to start doing interviews. I keep telling myself I'm going to do that, and I haven't done it yet. But that's another good question for Billy Godbold to answer. I've tested it many times now, and in fact, when I was sitting in for Brule with the guys from Engine Masters, we did that cam. We did a single pattern cam, not a reverse, but we did a single pattern cam versus a dual pattern cam, and like you might expect, the dual pattern cam made more power, but the single pattern cam did make more low speed power though. So maybe a single pattern cam will be more responsive under boost. And so then maybe the reverse pattern cam would be even more responsive. I just haven't seen that in my other testing. Doing any more 8.1s? Yeah, the 8.1's sitting over there. I have more stuff to test on. I have that Dart intake manifold. And I think I have another camshaft for it. Karen, I don't know what you mean by if I did all. Oh, you're answering somebody else. Okay. Jack stands and cinder blocks. Did a first start video on mine today. Yeah, the 8.1, you know, I was excited about doing that. I don't know how far we're going to take it, but I was trying to talk Oliver into putting that in the Nova, just twisting it in half. Jackson, you did a first start video on mine today. What did you start up? Oh, your 8.1. We'll all go take a look, then. That's cool. Do you have any how-to videos of piston ring gap? I think I do. I thought I did a ring gap video. No, I haven't. I did push rod length, I think. But that's actually another one that I want to do. Have you done anything with the 8.1 V10? No, I have not. What was the deal with the floating pickup in the oil pump at dead stock? That's the way that they came. Yeah, it was hinged. It was weird. I thought something was broke on it when I first saw it. I'm like, oh yeah, that's not good. That's why this motor's broke. But then after looking at it, that's the way that it's supposed to be. What about doing a turbo on supercharger like the? I've done compound boost stuff already. The 3.8 liter, the 3800, has a turbo and a supercharger on it. So that video is already up. I've also done it on a 4.6 4-valve where we did the Eaton supercharger and twin turbos blowing into that. So I've done a lot of that. Twin charge, and if you have it twin charged, you also have to have it twinner cooled. Hashtag twinner cooled. Is it possible that most of the cam wiping problems are caused by guys using too much spring pressure, more than they need for the real RPM they're going to be running, and are beehive springs better? I do like beehive springs. We've used them a lot. It is possible that guys overspring them and cause problems. When you do a flat tappet cam, particularly, you don't have to worry about that with hydraulic roller stuff. You're not, if you wear a hydraulic roller cam out, you really did something wrong. But on the flat tappet stuff, if you overspring it, it will do that. But a lot of the stuff that's destroying the flat tappet cams has nothing to do with that happening. Guys have been losing cams, even like if you have a dual spring, a lot of times they'll take the inner out or just run it on the inner, usually just running it on the outer. You can use really short ratio rockers, like Chevrolet makes some 1.3s that we use for break-in stuff sometimes. So you can try to be as safe as you can on the break-in and still have it be bad. And I think that a lot of that, some of it early on was the lack of zinc when the government decided that you shouldn't have zinc in oil anymore. Maybe the EPA, somebody. And then so that hurt it for break-in. And so the lack of zinc caused a lot of cams going flat. Now I think it's a metallurgy or a supply problem. Have you ever put a turbo on a 2.4 liter Camry? I have not. We had all kinds of problems with cams running flat when NASCAR made us run flat or mushroom lifters. That was way back in the day, right? That's why they have the cam tunnel oil baths. Cameron, what kind of numbers will I get with the Junkyard 5.3 intercooled twin 63 millimeter turbos, stock internals besides the larger cam and 862 heads? The 862 heads should have come on the motor. So if you put a cam in it, and you can, if you have it tuned right and have E85 and all that stuff, twin 63s, 57s, the right 63s might take you into 4-digit power range. What volumetric efficiency are you shooting for with the upgrades? I'm not shooting for a volumetric efficiency number. I would be shooting for, and honestly, given the fact I've never run one of these before, it's hard for me to decide what's going to happen. What I would do is basically base it off of a V8. So if I have 10-to-1 compression and I have a 224 cam and I have a head that flows 200 and I have a dual plane intake manifold on it, I figure it's going to make some sort of specific output number. And if I correlate that output number to a 4-cylinder, make half of that. And well, the specific output is going to be the same, but the peak number is going to be half of that. So I think that that's a pretty fair estimation. When you order aluminum heads, they come with what I think is too much spring, but everyone just bolts them on. Now, see, I found exactly the opposite when I've done the many head tests that I've done, because I've done head tests on the LS where we ran 20 or 30 heads. I did that on the 5-liter Fords. We ran 20 or 30 heads. I ran the big block, same thing. And what I found on those, in most instances, the supplied spring was like more for a flat tappet. And more often than not, we were running, in almost all those instances, we were running hydraulic roller cams. So there was not enough spring pressure for what we were trying to get done. And then we ran into valve float. Eric, I love your turbo intake video where you want to make power. That's it. The intake decides the RPM range, the effective RPM range, and then the turbo just helps it make more. Hey, all, just stopped in to catch up on the 4-cylinder Pontiac build. How hard has it been to find performance parts? It's not that hard because a lot of it is our V8 parts. Some of it is 4-cylinder specific, but like the camshaft, but the cylinder head is a V8. We can bolt V8 intake manifolds onto it once we put the right head on there. The piston is a V8. I think that the rod is also a V8. Obviously, the crank's not, but we're not changing that. Front cover's a V8. The pan's a V8. All that's pretty easy to get. The only thing is we gotta build a custom cam, or just regrind a camshaft, or have comp grind us one, which I'm going to do. So all that's pretty easy. How do you personally go about choosing a torque converter install? I don't. My my truck, my 2002 Silverado, has a stock converter on it, so it works really good. Is it true that the 4.3 is a 5.3 minus 2 cylinders? No, it's not. If you're talking about the new one, if you're talking about the new LT version, that's not the case. Its displacement is actually in between a 5.3 and a 6.2. Tests are cool, but full throttle, one manifold vacuum, 6,000 RPM doesn't give people a real idea about part throttle drivability. Well, they're not really here to find out about drivability. They're here to find out how much power stuff makes. So we can do drivability tests. You can do all of that out on the street, but that's not something you can do a video on, because all of that is subjective. The dyno is not subjective. It tells us the truth, whether we like it or not. John, what's the max boost you've attempted? I think that the highest boost I've ever run on purpose is the 29 pounds that we ran on the, I ran that on the Honda that I did for Bonneville on the engine dyno. We never ran that at Bonneville. And then I also did it on the Big Bang motor on the Gen 4 6-liter. GMPP Super Duty aluminum head is next. That stuff's really hard to find. Is the 4-cylinder Pontiac going to be bolted to an automatic or manual? It's not going to be bolted to anything. It's only going to be bolted to the dyno. There's no plan to put it in anything right now. Do you guys have E10? I think that they do in different places. And I still think the E10 would probably be better than 91. The older 4.3 is the older 4.3 Vortec motor is 3/4 of a 5.7 V8, but the new one is not 3/4 of a 5.3 or a 6.2. It's in between those two. How do you feel about the new big block versus a 572? I don't know what you mean. What 572? The new 632, I think, is a 1,000 horsepower deal. No, Patrick, the V8 cam won't work. The Trophy 4-cylinder had no holes for the pressure plates. Nope. Pump E10 is anywhere from 0 to 10%. It has that kind of range. Is the gasoline part of E10 at least good, or is that like 87? Because then maybe it's not really that good. .3 horsepower cubic inch is fairly easy on a good head. Cam intake 408. Yes. Yeah, take a look at the videos I have up on the 408 Ford stuff. Dan, we can't get a 3/4 race cam for the Trophy 4-cylinder. We can get a 2/4 race cam, though. Dom, you have a 542 valve, trick flow heads. Are they the as cast heads or the CNC ported heads? 10.5 to 1, 230 cam. cams. I don't know what intake you have on there, but that should make decent power. At what point on an LS is 93 not enough anymore? I think almost immediately for me, under any boost at all. Yeah, it might not even be a 1/4 race cam right now, Dan. Casey, there were 4 cylinders based on the small block Chevy. There were V4s though. Did you do injection setup versus a carb test on a trophy 4-cylinder? I would need a 4. I would need to do it on the V8 manifold, I guess. And that's not going to tell us anything that we don't already know, because I've run that test many times on something that would be a lot simpler to do. Fuel injection versus carburation, that's been answered long ago. Art, the L31, the 350 had less than 400 lift, but did it have 330? The V4s were done by SCAT, but they were race motors and they were based on the small block Chevy. I just like, people are talking about making power on it or whatever. I don't care that if I wanted to make power and I was doing a 4-cylinder, then I would be doing a Honda. But that's not why I'm doing this. I'm not doing this because it makes more power than anything else, or that it even makes affordable power, or any of those things. I'm doing it just because it's cool. Same thing with that 6-cylinder. I need to get a hold of Liv about that. Nope, no trophy 4-cylinders with LS heads, but you can put LS lifters in a trophy 4-cylinder. Snafu, I don't think I would go with a 400M over a 351 Cleveland if I was going drag racing. The 400M has really long connecting rods and really long push rods, and maybe if I had it and it was free, I would do it. But if I was doing a dedicated thing, I think I would pick the Cleveland. Admiral, your motor's assembled? Cool. 108 here in Northern California. Yeah, it's been hot. What's the biggest small block cubic inches? You can do bigger than 454. And they're still calling it a small block, but some of the altered bore spacing small blocks are bigger than that. I had a Victor Jr. single plane intake, 4.6 with adapter plates. Yeah, I don't know how well that works out, but a single plane is not good for drivability. It's 100 plus down here. It's not 108 though. It's 102 or 103. Not that that's any different. Oh, Lisa, what's going on? I didn't see you, Lisa. Come on, answer my question. What was your question, Lisa? Somebody else mentioned you. Yes, can I come home soon? I do want to come home. It's hot. Yes, girl, soon. I can't wait. Cameron, the stock rocker ratio on the trophy 4-cylinder is 1.5. A lot of guys erroneously think that it's 1.65 because they think that all Pontiacs are 1.65, but they're not. Almost all of the V8s on Pontiacs are 1.5. The Ram Air 4 was 1.65. 400 starts at 400 inches. There should be a way to stroke it. There are strokers. Somebody tell them the name of the guys that are doing the stroker 400Ms. I forgot their name. I've never dealt with them, but lots of guys have. Dan, there is it is an easy rocker swap as long as you got to get the stamped steel ones, or if you get there are lots of roller rockers that you put on there. Unfortunately, with the head that's on there now, and it has a pressed in stud, you can't make that work. You can only use the basically the long slot, high ratio stamped steel ones, and we just didn't have any of those. I have a stock 87 Mitsubishi 2.6 in a truck. Do they make a performance cam for it? Well, you can have one reground, obviously. But is it a turbo 2.6? 2 more minutes. Yeah, Fox, you can put the rocker ratio upgrades on everything. Like I said, it's only going to add 33 thousandths lift to this motor just because there's no lift to begin with. Ram Air 3, 224, 236. That's kind of like my go-to camshaft, 224, 232. You know, it's that extreme energy cam for the 5-liter for Chevys. They have them for every. That's a really kind of, and especially for a bigger displacement motor, which technically this is per cylinder, so it should work good. Cat's Garage. That camshaft isn't too big for this motor. I think the water pump's fine. What's the easiest small block to make reliable power with any of them? I haven't done the Mercruiser with the 460 Ford yet. I've seen them, but I've never done one. What's a 2GR cam? Bikes run at 13.2 to wider cars stay at 10 to 1. It's probably RPM, I would imagine. They don't run in an engine speed where detonation is nearly as much of a problem with that static compression. They probably also at the RPM range they're running have a lot more camshaft in it, so they have a lot less dynamic compression than a 13.2 to 1 would equate to in a typical automotive application. Okay, so the last question would be, what's the goal for the Trophy 4-cylinder in terms of power? I don't really have one. I wanted to make more. I wanted to make, ideally I'd wanted to make at least what it was supposed to make stock, and I think it could, given sorry condition. So I'd like to get it back to stock. But while being done, I probably will have the camshaft done. And then whatever that camshaft is, that's going to kind of dictate what the power output is. The head will get done, the camshaft, whatever the lift and duration are on the camshaft, and then whatever intake manifold we put on, it's going to do what it's going to do. Then we put other stuff on there, and not to, we are going to get more power, but I'm just going to show you what each thing does. What does a single plane do? What does a dual plane do? What does a 2-barrel? What does a 4-barrel do? What does the head change do? Hopefully, so because I would kind of like to run it. If I have a new cam done, maybe I can get another core from somebody and still run the stock cam and do a cam upgrade, because it'd be interesting to see what just the cam does and what just the head does and what the intake does. I put feelers out for the loan of a 4-barrel intake, a factory 4-barrel intake manifold for one of these. So I'm hoping to get the stock head done and be able to run it like that. If not, I'll just go right to the, bigger bore, flat top, later head and be able to run all the V8 manifolds. So whatever happens, happens. It's the way it's the way of the world. I'm going to turn off my poll here at 81%. The longer that I allow the poll to go, the more people go to the other side. Thank you all for voting in the poll. Some modern cars run motorcycle compression. Uh-oh. I've upset the car guys by saying that they run less. Thank you guys all for showing up. I will see you all tomorrow. Boom.